Welcome to day 17 of our challenge. Yesterday we have implemented Entity Framework, well the DB context, and today we will be taking a look at concurrency. Imagine a flight with only one remaining seat, and Alice wants to book exactly that seat. So she sends her request to the server, and the controller then fetches the flight Alice wants to book from the database. Entity Framework creates an instance of the flight entity in memory and loads the flight Alice wants to book into. The flight entity then checks to see if it has the capacity for Alice. And if the flight has the capacity, the flight entity instance books the flight. The flight entity instance books the flight and updates its remaining number of seats field in memory. Notice that the number of seats is only updated in memory but not in the database. So we need to save it and update the number of remaining seats field in the database to prevent other users from overbooking the flight. Alice booked the flight as expected without any issues. Now imagine a scenario in which there's also another user named Bob who wants to book the same flight at the same time while there is only one single seat remaining. In other words, Alice and Bob are going to compete for the same seat on the same flight. This situation is called race condition and falls into the category of concurrency subject in the context of computer science. They both send book flight requests to the server simultaneously. ASP.NET creates a new instance of the flight controller for each of them. Alice controller instance and Bob's controller instance both fetch the flight from the database now. Still, Entity Framework creates a different instance of the flight entity for each request in their controller instance. Then, each instance of the flight entity class checks for overbooking. The remaining number of seats field is equals 1 for both instances. So none of them detected any overbooking. Both flight entities then book the flight and update their number of seats field in memory again. Since the entity instances are not shared between Alice and Bob, the single remaining seat is booked for both now. So both controller instances eventually save their changes successfully and the number of remaining seats field is set to 0 in the database. So congratulations, the flight is now overbooked. Alice and Bob have to both sit on the same seat. Entity Framework provides a feature which can help to avoid race conditions in some situations. So as a matter of fact, one of the saved changes comments always delivers to the database first. And if the database could reject the second one, the problem would be solved. Well, but how can we implement that? How to configure the database to reject the second one? As I said, Entity Framework provides such a feature. It's one of the providers to implement the functionality though, and SQL Server providers does exactly this. So let's do it in action now. Okay, so the first thing that we have to do for that race condition is we go into our entities class, so entities.cs, and here inside of our onModel creating, we go ahead and add a concurrency token for the remaining number of seats. So right here, we can simply go ahead and enter model builder dot entity of type flight. There we go. Dot property. Property goes to properties dot remaining number of seats, right? That's one we are caring about. Now we can simply configure that property to dot is concurrency token. So we will just discover what that is concurrency token method is doing in a second. So inside of our onModel creating method here, we just configured that the property remaining number of seats of our flight entity is a concurrency token. Okay, so now let's hit run and see if everything compiles fine. Okay, everything compiled, that's fine. So unfortunately, there is not a simple way to test the effect of adding the concurrency token. However, I will now explain you what's happening in detail when we are adding that concurrency token method right here. So as I was saying, one of the saved changes comments always delivers to the database first. By setting the number of remaining seats field as a concurrency token, so if Alice saves the changes first, Alice wins the seat and Bob's booking does not take effect. Moreover, if Bob saves changes first, Bob wins the seat and Alice booking doesn't take effect. But how does that single line of code do it? But what does that single line of code do? When the application fetches an entity, Entity Framework snapshots the database value of the fetched entity and keeps the snapshot internally in memory. Entity Framework also creates a separate entity instance for the application to attempt to modify. The application then modifies the entity. Once it calls the SaveChanges method, the snapshot of the original database values is first compared to the current database values to see if another user has changed the concurrency token fields in the meanwhile. The point is that saving changes only take effect if another user has not updated the concurrency token fields in the database in the meanwhile. Let's consider our Alice and Bob analogy again. Imagine that Bob wants to book a flight. Entity Framework loads the flight Bob requests to book and keeps a snapshot of the original database values internally. Entity Framework also returns an instance of the flight entity to the application. Then the application reduces the number of seats while booking the flight for Bob, but before the application calls the SaveChanges method for Bob's request, Alice has booked the only remaining seat on the flight and successfully saved the changes to the database. So when the application attempts to save Bob's booking, the number of seats from the database does not equal the number of seats from the original database values anymore. Consequently, the application throws DB update concurrency exception while saving Bob's booking changes. Now let's move on and handle this exception. Okay, so we set the remaining number of seats to be the concurrency token or to be a concurrency token. Now let's go to where you can really book a flight. So move to the flight controller and go right into the book method right here. Well, you can see that we got that overbook error, right? So not enough seats. So the overbook error here is trying to handle the conflict when you want to book more seats than there are available. But the race condition that we have discovered earlier is something different, right? It's about having the same requests, well, in a very short amount of time between those SaveChange comments. So 2 comments or 2, well, calls which get in between. Now, to handle this one, we simply wrap that SaveChanges here into a try catch, because this is exactly what will happen now when we got remaining number of seats as a concurrency token. So it will now check, as explained in the earlier presentation, that if you want to book a flight and someone else books the last seat, you will now get a concurrency exception. So we wrap that inside try entity SaveChanges, right? And we want to catch an exception, which is DB update concurrency exception. All right, so let's import a namespace. And as I said, that exception will get called if someone else books the last flight before you submitted your changes. So someone else, well, booked the flight and saved the changes, and now the value is 0, there is no flight anymore. And just when SaveChanges runs and it sees, oh, the value is already null, the concurrency token is null, right? Then you will now, well, get an error, the DB update concurrency exception. And we can handle it in an easy way. Let's just copy the conflict from above. So return a conflict, and let's say, for example, something a little bit general. An error occurred while booking. Please try again. Great. Okay, and that's all we have to do. So let's just run the application and try to book something. Great. So now registered, search for flight. I'm gonna now book something, let's say 3. We still got our message here, not enough seats. And when I book 1 flight, for example, or 1 seat, my booking works. So as I already said, there's no simple way to test for concurrency, because 2 calls have to be, well, sent at exactly the same time, or well, maybe there is a delay because of internet connection where someone else saves the changes first before you do. So for now, implementing what we have done so far will be enough to take care of the race condition if it ever takes place.